We're going to talk about conditional statements in this lesson. This little slide is just for the notes for me to tell you how to fold your paper that we did in class the other day. And if you didn't do the foldable, you could take a piece of paper and you could hamburger fold it, hot dog fold each half, and then hamburger fold again, and then cut and rip so that you create a little booklet that has, I call them windows, should have 4 windows that will open. And the reason I have you do that is because now you can put this information into it. And what I would do on the very front cover in the top left, that's what I have this up here for. On the outside of it, I just write conditional statement. And then, right next to conditional statement, I would keep this on the outside. I would write a statement that can be written in if-then form, because that's what a conditional statement is. Notice statement is still in there. That's what we talked about earlier. We talked about in a different lesson, something that can be written that is either true or it is false. I would also put on the front cover this notation. That's going to be helpful to us because, remember, as mathematicians, we like to shorten everything up so we don't have to write as much, but at the same time allow everybody to understand what's going on. So this notation says if P, then Q. If P, then Q. So it's in if-then format. We have the 2 little parts. Now I have a little example here. So I would open up the little window, and now you have the 2 sides of that. And what I would do is I would make this part right here be the fold. So everything to the left of the comma, put on the left window, and everything to the right, put on the right. It says, if an angle's measure is less than 90 degrees, then it is acute. That is a conditional statement. The hypothesis is everything that's after the if up to the comma. So that's referred to as the hypothesis, excuse me. And then we a lot of times use P as the variable for that, and really you could use any letter you want. If you don't like P's and Q's, use A's and B's or X and Y's. It doesn't matter. But then when you move on to the conclusion, that's the part that's at the end. It concludes your conditional statement. And in my example, I'm using Q as the variable for that. So when you look here, you have if P again, big arrow, then Q, which has words for it as well. And again, being it's a statement, I can come up with the truth value and determine whether this one is true or false. So if it's true, I would not be able to come up with a counterexample. But if it's false, then I should be able to come up with a counterexample. Now in this one, the truth value, as you notice, is going to be false. And some of you are thinking, that doesn't really make sense. But here's what I want you to think about. I could come up with an angle that's less than 90 degrees, but is not acute. And my example for that is an angle with a 0-degree measure. Here's one side of the angle, and then the other side would be right on top of it. So I'd have a 0-degree angle. When I look at this, that satisfies my hypothesis. If an angle's measure is less than 90 degrees, 0 degrees is less than 90 degrees, taken care of. Well, my statement says, well, then it has to be acute. But remember, an acute angle is one that's somewhere between 0 and 90 degrees, but do not include 0 and 90 degrees. So 0-degree angle, less than 90, but it is not acute. That's why I have a false conditional statement. My next one is the converse. So I would close up your little foldable, and then in the top right corner, on the outside, I would write converse. And I don't really have a definition for it. I've just given you the symbolism. So on the cover, I would just write converse, and then if Q, then P, that you're seeing there using the symbols. Now open up your foldable, and here's my example of the converse. So I've taken that first conditional statement, and I'm taking the converse of it, which just means switch the hypothesis and the conclusion around. So what used to be the hypothesis now moves to the end and becomes the conclusion, and what used to be the conclusion now moves to the beginning and becomes the hypothesis. And what I'm going to do in this one is I'm going to go through and I'm going to identify. This is my hypothesis. It's the stuff that's after the if and before the comma. I'm going to identify my conclusion. It's right here. It comes after, then, and before the period. Remember, hypothesis will not include the if, and the conclusion will not include the then. Well, I think back now, this says an angle is acute. Well, from before, my last statement, that was the same thing as what I used as my Q variable. This is the same thing as my P. So as I notice in my statement, when it's written out and I identify the hypothesis and conclusion, the P and the Q got flipped, and that's what happens in the converse. Those two things are flipped around. Truth value on this, well, this one tells us the angle is acute. Then its measure is less than 90 degrees. Well, the truth value on this one is going to be true, because I don't care what acute angle you pick, its measure will be less than 90 degrees. So notice the difference. The first one, my conditional statement was false because of the order, and now it becomes true. So it depends on how you say it, in what order, on whether that statement will be true or false. Next one is the inverse. Again, close up your foldable, and then I would put it in, I would write inverse on the cover of the bottom right corner. And then also on the outside there, use that symbolism. Now, notice it has the little squiggles in front of the P and Q. If you remember back to our lesson the other day, that meant to negate it. So we are going to negate what was the hypothesis and negate what was the conclusion, but keep it in the same order. Now if you open it up, here's my example. So again, I went back to the original conditional statement, and I negated the hypothesis, which is here. Notice there's the negation word, not, and I negated the conclusion. And again, not is in there. And if I think back to that conditional statement, this really was P, except it's saying the opposite of it, because P said an angle's measure is less than 90 degrees. Well, this is saying it is not, so I'm going to negate the P. Here's the Q again, except it's saying the opposite of it, so I negate it. Well, now I have if, and the way I would read this, it says, if not P, then not Q. Truth value for this one, also going to be true. Because if you look at all the examples, an angle's measure is not less than 90 degrees. Well, not less than 90 degrees means that it is 90 degrees or it's greater than 90. If you look at any of those scenarios, none of those kind of angles are acute ones. So this one comes out to be true. And then our last one is the contrapositive. So if you close up your foldable, I would put this in the bottom left. Just write contrapositive on the outside, and then there's the symbolism for it. Notice on this one, negating the P and the Q, and you've changed the order. Open up your foldable, and there's our sentence. Again, going back to the original conditional, I'm going to negate both and change the order. So if an angle is not acute, then it is not less than 90 degrees. Again, I'm going to identify my hypothesis and conclusion. Hypothesis. Here is the conclusion. There's the Q from earlier, except we are negating it again. And here's the P from earlier, except we are also negating it. So if not Q, then not P. Truth value on this one comes out to be false. So in this one, my counter example, if an angle is not acute. So again, I'm going to go back to that same example that I had before. I'm going to go with my 0 degree angle. That is not acute. Well, my contrapositive is telling me then its measure is not less than 90 degrees. Well, 0 degrees is less than 90 degrees. Therefore, I found a counterexample to disprove it, which means that it has to be false. Now, the logically equivalent. We had 4 statements there: conditional, converse, inverse, and contrapositive. Some of them are always going to have the same truth value. So when you look at it, if this is your foldable again, when you look at the left side, the conditional and the contrapositive, they're always going to have the same truth value. So if the conditional statement was true, that means the contrapositive will be true. If the conditional was false, the contrapositive will be false. You don't even have to look at the contrapositive if you know that the conditional statement was true or false. Contrapositive guaranteed to have the same truth value. Now, if you look at the other side of your foldable, dealing with the converse and the inverse, those two are always going to have the same truth value as well. The part that you need to be careful on, I only gave you one example in this foldable, and in this foldable, it appears that the conditional and the converse, have different truth values. Will this always happen? No. There might be that scenario where conditional is true, converse is true. So that means that everything will be true. So it may look like that at times. In the one example that we had today, they switched. Conditional and converse had different truth values. But just keep in mind that the two on the left are always going to have the same truth value, the two on the right always have the same truth value, and then what happens when you kind of go from left to right depends on the statement. Now what I want to do here is I want to take a statement, a five-sided polygon is a pentagon, and I want to turn it into a conditional statement. So what I'm going to do is I'm going to write it in if-then format, keeping the same meaning. And sometimes the order is going to be very important in how you say it, and sometimes it's not going to be that big a deal. But in this one, I'm going to start off with if a polygon has 5 sides, so I'm still looking at a 5-sided polygon, started there, and then go on and say, then it is a pentagon. Well, that's right here. So I really have my conditional, call it P, I have my, my hypothesis P, and then here's my conclusion Q in if-then format. And the last thing I'm going to look at is the truth values on determining whether a conditional statement is true or false. I'm going to start you off with the blue here. If you earn 100%, then Mr. Rood will give you an A. So that's what's going to happen. Now I'm going to go through the different examples of what could happen. So you earn 100%. Well, based off the hypothesis, that part would be true. Mr. Rood gives you an A. That would be true. Then the statement as a whole, everybody's going to tell me, well, that's true. That makes sense. Now I come down here to my next example. You earn 98%. So that part would be false because, go back to the blue, it says you earn 100%. You didn't get that 100%, so that part is false. Mr. Rood gives you an A. That gives me the conclusion part is true. Now that's going to tell me that the statement as a whole, believe it or not, is true. And here's why. My blue statement tells you what will happen if you earn 100%. It doesn't say anything about if you don't earn 100%. So in this case, I want you to assume true unless it could be proven false. So it says 98%. I don't know what's going to happen if you get 98%. Apparently, I can give you an A. We're going to always go with assume true unless you can prove it false. My next one now, this one, you earned 100%. So that makes that hypothesis part true. Mr. Rood gives you a B. That makes it false. That makes the statement as a whole false because